We'll start with some questions from homeworks, and then we're gonna go on and talk about the next set of topics. Who's got some homework questions for me?
Let me get to the homework, so I got a question mark somewhere.
Yeah, no worries. We got some minutes.
Mr. Gluck, is that like 7:59 Sunday?
Yeah. 32, part B.
32.
She's not working off my phone. This is our last room. Less than 1. Yeah, less than 1. Okay,
So this reads that the half-life of a certain radioactive substance is 65 days. Suppose there are 3.5 grams initially. Express the amount of substance remaining as a function of the time t.
So PFD, 3.5, 1.5, so 1 plus.
Yeah, I'll just write it this way.
Yeah.
You simplified it.
T over 65.
Awesome.
My T was in days.
Good. When will there be less than 1 gram remaining?
Yes.
So we're basically solving this equation, right? So I'm just gonna, again, do this on my calculator. So 3.5 times 0.5 to the x divided by 65. And then just make that 1. So the y scale, I'm just going to make from 0 to 3.5.
Did you put the Y2 as just 1?
Well, I made the yeah, y2 is just 1, yes. Yeah. And I don't know, this is days. So like 1 half-life, you're going to be like 3.7 or 1.75,
Yes.
and then half of that is going to be less at least. So my max is going to be like 2-ish half-lives.
All right.
So 2 half-lives is like 130 days. So I'll do that as my my x max,
Sweet.
and that should do her for me. Let's hit graph and take a look. So there's my curve. There's my 1 gram. There's my intersection. So second trace, intersect command, enter, enter, enter. So 117.47 or so. So I might say after 115 days. So I just round it up, and that'll be the nearest. It'll be less than 1 at that point, and that's the nearest day that'll give me less than 1. That feels like
Sounds good.
probably how they wanted us to answer that. Is that
Sounds good.
okay?
I was just being confused when I typed in my calculator.
Yeah. You guys are so supportive.
Yeah.
What else? You guys got some more?
You got it.
Okay. We got I think the next class will be just like a Delta Math day. We can take like a timeout and just like, here's a bunch of practice to try. Get some immediate feedback.
All right. 42.
42. We're doing some logging, huh?
Yep, some log.
Call me Paul Bunyan. He's a famous lumberjack
Yep.
because he likes logs.
He has bunions.
He has bunions. He has a blue oxen named Babe. Yeah. All right. So this is the problem. The directions ask to simplify without a calculator. I have some stray crap in there from when I screen grabbed it. That's what the extra gobbledygook is above and below because they're just not very well spaced. So I'm just going to rewrite this as a exponential because it'll probably be easier in this case because it's kind of like a confusing looking thing there, right?
Yeah, just a tad.
So I'm going to work on taking 1 over the 5th root of 36 and trying to write that just as a power of 6. If I'm able to do that, then I'll know what y is immediately, right? So,
Just 6 to the 5th.
no, unfortunately. So I know that I can just put that 5th root around the 1 also, because any root of 1 is just 1,
Yeah.
right? And now what I can do is I know that that 5th root is the same as like a 1/5 power. And now I need to rewrite 36, or 1 over 36 is a power of 6. So I know 36 to the negative 1 is the same as 1 over 36. That'll get rid of the fraction part for me.
Sweet.
And then I should recognize 36 is 6 squared. So I have this.
Yeah, a couple exponents.
Yeah, I have 3 exponents, but I know that the exponent of an exponent I just multiply. So 2 times negative 1 times 1/5 is negative 2/5. So that's going to tell me y is negative 2/5.
Sweet. Yeah, I'll probably get 2 I got it there, but there's
Oh, yeah. That's pretty good. And again, can you check this?
yeah, just toss it.
Yeah, you just toss it into your calc, right?
Math base.
So math, and I do log base 6, and then 1 over, and then I can do 5 math, command 5, 36. And that does give me negative 2/5. 0.4 is just the decimal approximate, you know. But so definitely checkable, right?
Put 6 to the power of 0.
Facts.
Facts, yeah.
Facts right there.
Facts.
All right. Who else? Boyd?
Go over 80, please.
80. Whoa.
Okay.
Yeah, that's what I'm talking about. Not messing around there. All right, this one says we're asked to expand the logarithm using our properties of logs. So first thing we look for is a quotient property. Got none of those.
No.
Next thing we look for is a product property. And I noticed that, well, sure, there's a multiplication going on between the 1,000 and the x to the 4th.
Separate them up.
So we can do that. And
Power.
reminder again, what is the base of a logarithm that just says log?
Base 10.
That's base 10. And I recognize 1,000 is 10 to the 3rd, right?
Yeah.
And wait a minute. The log base is matching the base of the logarithm. So what can happen?
Log 3, right? No, they cancels out.
They cancel out.
Left with 3.
And I'm just left with a 3 there. Woo!
That's awesome. 3 plus log.
And then if I look at the next one, that's just a power property situation. So the exponent of 4 just moves to a coefficient, and that's as good as we can do.
Awesome. So
You didn't think about to reduce the logarithm there like we had done earlier, probably.
I was just like, I was thinking it was gonna be
3 log 10 plus 4 log x. Yeah.
can we get a nice little 73?
73, sure. Certainly. No problem. Okay. All right. Again, same directions here asking us to expand.
Yeah.
First thing we look for is quotient property, and I do see division going on. So I can just write that as log of the numerator minus log of the denominator. And then if I look for product properties, there's no product properties. Look for power properties, there's none of those.
So we're just left there.
So this is done.
Alright, I just gotta add it. That's under product.
That's quotient property that we did. Alrighty. Let's. Oh, Boyd, we'll do one more.
I just want to make sure I did 82 correct. So,
Yeah, which let's see, you get 1/3 natural log x minus 1/3 natural log y.
okay, I saw them both in the numerator and the denominator, so I like canceled them out. So we don't do that.
Correct. So if I have like square root 3 over square root 4, that's not equal to just 3 over 4, right? So you can't make that same cancellation with a cube root or a fourth root or a fifth root or whatever,
So
right?
there's like X and Y.
Exactly. If they're both the same variable,
There's
then
no way to tell.
you could cancel them out. But yeah, they're variables. So
Okay.
does that feel good? Great. All right. Welcome back. Today we're doing 15.4.
Mr. Cool, if we're doing 15.4 today, does that mean we're not picking up the work list?
I don't think I remember to say anything about it last time, so we're not going to do it today.
Oh, okay. Thank you.
So that doesn't seem hardly fair. But next time we will.
Okay.
All right. Kind of putting all the pieces together here.
Let's go.
So we're going to be solving exponential and logarithmic equations today. So I'm just going to kind of do some examples of some of the different techniques that we can use and talk about when we might want to use that given technique. So we'll start with exponential equations. So let's say we have one that looks like this, where I have an x in just one place. One technique I can try to use is try to rewrite this equation so that the two sides of the equation have the same exponential base. That in this case, they'd be both base 1/3. If I can do that, then I can just set the exponents equal to each other and solve. So the first thing I'm going to do is try to get the base on the left-hand side, which I know is 1/3, by itself. So I have to get rid of that 14 that's out in front of it. How am I going to get rid of that 14? Yeah, just divide it over. 126 divided by 14 is 9. And now what I want to do is try to rewrite 9 as a power of 1/3. So I know I need to make a fraction here. So maybe I'll do that. Right, if I just use a -1 exponent, that'll make a reciprocal. Good. So far, so good. And I recognize that 1/9 is the same thing as 1/3 squared. And when I have an exponent of an exponent, they multiply. And since the bases of my exponentials are the same, I know the exponents have to be equal. Which gives me an answer of -1. Okay. So that's one way you could do this. Another way you could do this would be to use a logarithm. So we'll start the same way by getting the exponential, or the base of to get that exponential piece by itself. And now what we're going to try to do is I want to try to get rid of that exponent base of 1/3. What cancels an exponent base of 1/3? Nope. So what is going to cancel an exponent base of 1/3? Nope. Nope. Okay. This is the key. This is the big idea that we've been building towards. What operation is going to cancel out an exponent base? A logarithm. So what base logarithm am I going to want to do? Not 3, 1/3. I want the base of the logarithm to match the base of the exponential I want to get rid of. So I would do log base 1/3 to both sides. And as we've established last time, log base b will cancel with exponent base b, leave me with just the exponent. And then I can add 1 over. And that's now just calculator time for me. So math, log base, 1/3, 9, and then plus 1 outside. And I get -1 again. Either approach is correct. Either approach is appropriate. Overall, which one is the more advantageous approach? Is probably this one. The reason being that it's sometimes going to be really difficult to rewrite the right-hand side with the matching base. For example, if that was 1/3 x to the negative 1 equals 8, what the heck are you going to do there?
You mean, that makes sense.
Yeah, right. You'd use a logarithm,
Exactly.
right? Like the logarithm is like the skeleton key that unlocks any lock, any exponential lock.
Universal.
Yeah, as opposed to getting the bases to match, which is like good, it's effective, but like, boy, sometimes that's a bugger of a problem. Let's do another. Okay. All right. First step that I want to do here is divide the 12 to both sides. Excellent. And then I can reduce that, right? Both of those are divisible by 3. And at this point, you could split and do each of the two different methods. Hopefully you can recognize that how is 9/4 related to 3/2? It's the same thing squared, right? So you could say then x over 5 is equal to 2, or x is just 10. Or if you wanted to use a logarithm, you could use log base 3 over 2. The same base as the exponential. So those guys cancel out. So I just multiply the 5 over. And it's calculator time. And I get positive 10 once again. Once again, either method is appropriate, perfectly fine. Let's look at one that's a little bit, well, I would say it's considerably different.
I don't think there's a coefficient button on the calculator.
A coefficient button on your, what are you trying to type in?
Like log, like, and then 2 after, or 2 on the bottom.
Right, so you can't do that, you have to use the change of base formula. So if you're trying to type in what we just did, you do 5 times, and you just do log of 9 over 4 divided by log of the base you're trying to use.
Oh, okay.
And then it'll spit out. Is that, you remember that now?
Yeah.
Okay. And if you want to borrow at any point one of the calculators that has the other operating system, you're welcome to grab one. So you don't have to keep doing that, but that's how you would do it on yours. All right, let's look at a extra strength tricky example here. Yeah, get ready. Hold on to your butts.
We're not holding. Holding.
We all thought it was funny, though. All right, so here we go. We got this, right?
What is that line over the three? Oh, it's negative?
That's a negative x. It's just in the exponent, right? All right, what do you notice about this one that's different than the previous ones? I got x in more than one place. That's the big thing that I would want to notice. That makes it definitively more difficult, right? All right. My first order of business is I want to get rid of the fraction. So I'd multiply both sides by 4. So far, so good. The next thing that I'd want to take care of here, now that I got rid of the fraction, is I would want to work on this negative exponent. So we have the negative sign in the exponent here. What can I do to both sides to take care of that negative in the exponent? This is the trickiest step here.
Turn into a no.
So you could write that as 1 over 3 to the x. That would not be incorrect to do. And in which case, if you'd like to think about it that way, that's fine. We can do that. That's not a bad idea. Well, it's going to turn into, even from here, it's going to turn into the same next step, whether we show this intermediate or not. So now instead of thinking about getting rid of the negative, I don't want to get rid of the fraction again. So what do I do to both sides to get rid of the fraction? Multiply both sides by 3 to the x. Yeah.
So you could have just thought that.
You could have done that at the previous step without showing this one. It's not wrong to do that, but that's what we're doing. So 3x times 3x is
9 for 3, 2x, right?
to the x plus x, or 2x, yes. Good.
Mr. Cool, may I use that?
Absolutely. What's 3 to the x over 3 to the x?
1.
1. And then we just have 8 times 3 to the x.
Was that just going to, or you
Can't multiply them together because they have different bases and different exponents, right? So if the bases were the same, we could add their exponents, like we did to the 3x times 3x. Or if the exponents were the same, we could multiply the bases together and keep the exponent the same. So 3x times 3x, you could have also written as 9x. Would have been okay to do it that way. All right. So what I'm going to do is I'm going to move everything onto one side now. Like this. And I'm going to make the following observation. Notice that I have multiplication in an exponent, right?
Yep.
What is multiplication in the exponent the same as? It's the exponent of an exponent. So this could be thought of as 3 to the x squared.
It's like, it looks like you got like scratched by a horse.
Hey, don't have to be all judgy and like,
No, we're not judging.
like, oh my, look at this weird thing on your neck. Everybody look at it. Don't be self-conscious about it at all.
We just feel bad getting abused.
No, it's like concern.
Lip bender.
It says lip bender, I think.
No,
it scratches.
That's what it says.
Sorry,
Look at your neck. Sorry,
Okay.
Oh, I thought she used a pen.
Let's
She used her nails.
Those are some long nails.
Let's try to refocus now that we've
Apologies.
No,
embarrassed Luke enough.
Yeah, I'm okay, guys.
Okay. So look at what we have here. If you squint at this hard enough, what other kind of problem does this look like now? What?
quadratic.
Yes.
Oh!
Yes.
Loki, I'm
Kaden,
good
you need
with
to
this class.
speak
Oh, don't.
So let's just imagine. Hi, Miss Anderson.
So weirdos.
Yeah,
This is for the ice cream truck tomorrow for the tickets for your CT.
lovely. Thank you. So if we just imagine.
Also, you gotta round up.
That instead of 3 to the x, we just have some different variable. Let's call it a. Now it looks explicitly quadratic, right?
Oh,
Yes, Kate.
let A. So he just made a variable.
I just replaced the 3 to the x's with a different variable name so that instead of looking kind of like a quadratic, it is just a quadratic.
Just hit the store button on his tab.
Yeah, that's exactly what I did.
Just think about it.
All right.
I know that.
So for right now, this problem has changed from a exponential equation to a quadratic equation, which we know how to solve. How do we solve a quadratic?
9 plus
Full foil.
You could try to factor, that I think is the F word you're thinking of. Are there two numbers that multiply to give you 1 and add to give you -8? None that I can think of. What should you do if you can't factor it?
formula.
I would use the quadratic equation, yes, or the quadratic formula. So A equals -b plus or minus the square root of b squared minus 4 times A times C all over 2 times A.
What do you do? That's disrespectful. That's the one that's not taking notes.
Okay, and I'm going to go ahead and simplify that a little bit further. So I can break up 60 into 4 times 15. And that's helpful because the square root of 4 I know how to do. I can then reduce this fraction into that. But we're not done. Just hold up and let me finish this one before you guys go sprinting off to lunch, okay? So we have a solution for A, correct? But A is not what we're trying to solve for. A is really 3 to the x. So let's go ahead and put that back now. So I'm going to write this as 2 separate equations. What do I need to do to get rid of that exponent base of 3?
Log 3.
Log base 3 of both sides. Excellent. Okay. So the log base 3 cancels with the exponent base 3. And from here, it's just calculator time. Okay. And when we come back from lunch, we can talk a little bit more. Exponential equations, right? And we just showed you kind of the hardest version that we'll see, where our exponential equation is like nested inside of a quadratic equation. So that's like the hardest version that we'll see in this class of solving an exponential.
That was definitely 61.
Let's look at some logarithmic equation examples. So let's say that we solve, or want to solve 3 times log of x squared equals 6.
Divide the 3 over to start us out.
Great, so the first thing I'd want to do is get the logarithm part by itself, so divide both sides by 3. Okay. Now, what's going to cancel out a logarithm?
They're reciprocal, right? Or no, what? It's like 3 or 2. It's a 10.
Great, so an exponent base, right? So what is the base on the logarithm here? 10,
Which is
because if it's not written there, it's a 10. It's called the common logarithm. We talked about that last time.
common and natural.
Yep. Natural log is log base e. So what am I going to do to cancel out the logarithm? I'm going to use log, or exponent base 10. So I'm going to draw this like absurdly large number 10 here to really emphasize that that is the base of a logarithm. I'm not multiplying both sides by 10. I'm taking 10 to the power of the left-hand side equals 10 to the power right-hand side. Exponent base 10 cancels the log base 10. And I have that x squared is equal to 100. So square root both sides, x is plus or minus 10. Very good. But for logarithmic equations, we have to do something else. We have to check. So what I need to do to check, because I can get extraneous solutions just like I could in the rational equations. I got to plug these back in, and if the inside of my logarithm, I'm left with negative or 0. Negative or 0, it'll be extraneous. Otherwise, it'll be fine. So if I plug negative 10 and square it in, I get positive 100. That's okay. If I plug positive 10 in and square it, I get positive 100. That's okay. Both of these answers are keepers. But we do need to make sure we're checking. All right. All right, one more example. And this is kind of the worst case scenario that you'll have to deal with for a logarithmic equation. It's like an answer that doesn't count. The technical, well, you would just cross out whatever solution didn't work and just keep the ones it does. So what's happening is the equation that you end up solving for would be like a polynomial equation whose domain is all real numbers. the equation that you're actually solving for, the original equation, was like a logarithmic equation or an exponential equation or a rational equation, whose domain could be restricted. So you could get an answer from solving the quadratic that actually falls in the restricted part of the original. That's what an extraneous solution is. All right. So let's take a look at this guy here. Yeah, isn't it? That's ln.
Yeah.
L is in lime, N is in Nancy. I always write them cursive.
Natural log.
That stands for natural log. Logarithm natural is the where that abbreviation comes from. So let's take a look at this, where we have the natural log of 3x minus 2 plus the natural log of x minus 1 equals 2 times the natural log of x. Woof, right? What should we do first? We do need to do that, but we can't do it yet, because what we can't do is do it piecewise. We can only do it to like one whole side at a time. And then this isn't going to cancel, like those won't cancel because they're being added. So we don't want to do that yet. We do want to do that eventually, though. Somehow I have to turn these two logarithms into one logarithm.
Oh, we gotta use our
Not the distributive property. We have to condense these two logarithms using the product property. Very good. Since they're being added, I can combine them together using the product property. And then I have an issue over here with this coefficient of 2. Can I do something with that?
ln x squared.
Yeah, I can use the power property to rewrite that as the natural log of x squared. And now, Caden, now we're ready to cancel the logs, because I have log of the left-hand side and then log of the right-hand side. So what base is the natural log? So what exponent base am I going to use to cancel them? So I'll do like e to the right-hand side and e to the left-hand side. E is a number, right? It's like 2 point whatever, blah, blah, blah. It's just like an irrational number like pi. So I went ahead and foiled that piece out as well. But what are we left with here? What kind of an equation is this?
Let's move the x squared over again.
It's a quadratic. Yeah, so let's move the x squared over. And to solve this quadratic equation, I can use the quadratic formula. Since leading coefficient is not 1, I would just use the quadratic formula. This one does factor, but it's going to be like the same amount of work as the quadratic formula. And I can't usually tell from right away if it's going to work or not. So I would just use the quadratic formula here. So negative b plus or minus negative b squared minus 4ac all over 2 times a. So 5 squared is 25, minus 16 is 9, the square root of 9 is 3. 5 plus 3 is 8, divided by 4 is 2. And 5 minus 3 is 2, divided by 4 is 1/2. But I'm not done yet. I got to go back and check. So if I take x equals 2, back to the beginning, 3 times 2 minus 2 is positive. 2 minus 1, positive. Regular old 2, positive. So that one's good. Now let's try a half. 3 times a half minus 2 is negative. So I don't care what happens after that. I already know that that one doesn't count. That one is extraneous. I'm left with just one solution. X equals 2. All right. We're going to stop here. You guys should be able to do up through 130 now. What is it? Is it 99? What is the first one here? Yeah.
5 plus 3 is 4, 2, and 5 it's just breaking it apart.
Okay. Is this stuff due this weekend? Next weekend, man. Next weekend. So Sunday is 17 to 98, right? That's the problem set due Sunday. Next Sunday we'll have 99 to 130. We'll do a delta math and do the homework quiz next time. The homework quiz won't have any logs on it. It'll just be through like the exponential stuff we did. So that's what we'll do next class, is do the homework quiz and then do some delta math stuffs. Just take a pause, let us kind of all get caught back up, because I'm guessing a lot of us are kind of far behind on the homework.
That's true.
Unless your name is Nathan or Boyd.
Yeah.
43 ain't bad. Yeah, what's up, Bree?
Actually, I'll ask you in a second. 1 second.
Okay.
Sorry, I just need to check something.
Yeah, take your time. I'm going to stop the recording, though, because I think I'm done talking.